Hello everyone. In this lecture we are going to discuss the full subtractor. So let's discuss. Full subtractor is capable enough to handle the, you can say, if there is any previous borrow is there. So let me elaborate so that you can understand what is the meaning of borrow in or previous borrow. So let's draw the truth table of full subtractor. So the truth table looks like this. In this, if we talk about, let's fill the values of difference D and borrow out. So let's say when we find out the difference, first we find out the difference of these two bits, and then if there is any borrow, then we find out the difference from the resultant difference, right? So 0, if we subtract 0 from 0, it will give 0, and then if we find out the difference between 0 and this 0, it will give us 0, and there's no borrow out. This is also 0, right? There is no borrow. Now if we find out the difference of this 0, 0 will give us 0, and 0, 1. So if you are having 0 and you are subtracting 1 out of 0, this, then you have to take the borrow, right? So in that case, once you take borrow, you will get difference as 1. So the difference is given as 1, and you have also taken a borrow. So there will be borrow out. I hope you are getting it. Now when we find out the difference of 0, 1, there is a difference of 1 you will get here because you need to borrow. So the borrow will be 1 here, because in order to subtract 1 from 0 we need to take borrow, and once you take borrow, the difference will be 1 of this, and then you will subtract 1, and 0 will be subtracted from the resultant 1, right? So it is 1 minus 0 here, and it will give us 1 only. So here the difference is 1 as well as borrow is 1. Now if we consider here, we need to take borrow, and the difference will be 1. So we are taking borrow here, and the difference will be 1 here, and 1, when you subtract from 1, you will get difference as 0. Now here 1 minus 0, you can see it is 1, there's no borrow, and 1 minus 0, again there will be 1, so difference is 1, but without taking any borrow. Similarly here 1 minus 0, it will give you 1, and 1 minus 1 will give you 0. So there is no borrow and there is no difference. In this case 1 minus 1 will give us 0, and 0 minus 0 will give us 0. So difference is 0 and borrow is also 0. In this case 1 minus 1 will give us 0, and 0 minus 1. So we need to take a borrow. So there will be difference 1, and borrow will also be 1, right? Now let's find out the Boolean expression for this. So first we try to find out the Boolean expression for difference D. Okay, so let's find out for D. If we try to find out this difference, let's make the K map for this. So the K map will look like this. Let's fill the values here. So first place is 0, then second is 1, third is 0, third is also 1. I'm taking the values from D, and then the fourth is 0. Then this place is 1, the next is 0, and the next is 0, and this place is 1. So now when you look at this, you will again recall that this is a checkboard problem. And we have already discussed when such kind of KMF will come up, then we just need to take the XOR of all this. So X XOR Y XOR borrow N. So this will be the Boolean expression for difference D. Now let's find out the Boolean expression for borrow out. So for borrow out, so I'm writing B out. Let's draw the K-map for B out. So the K-map will look like this. Now let's fill the values here. The very first place is 0. Here we are taking B out. Then the next place is 1. Then the next is 1. Then the next is also 1. Then next is 0. Then this is also 0. Then this is also 0. And here it is 1. So when this is the K-map, and we know that this is X bar, this is X, and here we are having Y bar B in bar, Y bar B in, this is Y B in, and this is Y B in bar, right? B for borrow, right? So let's find out the expression. Now we need to form the groups. So the possible grouping, what we can do here, pairing like this, we can do this one can be paired like this with this one, and this one can be paired like this with this one, right? So there are three possible groups. We will get three possible values, right? So borrow out will give us this, the very first thing, which is in yellow. So I'm writing in yellow here. It will give us X bar, and because Y is changing here, so it will give us B in, right? Then plus next group is red. Let's say I'm writing, if I write in red, it will, X bar is converting to X, so it will give us Y B in, right? Now there is another group also. Another group is in white, so let me write in white. It will give us X bar, and here B in is changing, so X bar Y. So this will be the expression for B out, and this will be the expression for difference. So please do remember, you can form the circuit for this. It is not very difficult. So let's look quickly see the circuit realization. I'm just drawing here. So let's say there are three inputs we are having. So let's draw it. One, let's say this is X, this is Y, and this is C in. Now if we want to take the complement, we can have complement here. Like this. If we want to complement of it, we can take it like this. Now if you want to complement of we do not require the B in complement because in the expression we don't have any complement, right? So let's take these two complement only and let's connect it like this, right? So this is I'm taking as X, this is Y, and this is borrow in. Okay, now for D it is XOR, so you can take XOR like this. Now you connect X and Y, so this is X. Let me connect with some other color. So this is X and this X is moving ahead like this and getting connected here. Then the next thing we need to pass as Y. Y is given here. Y we can pass like this. Disconnected. And now because we need another XOR with B in, so let me pass B in from here. This is B in and it is going like this, and there's another XOR. So this is our D, and D is X XOR Y XOR B. Now similarly we can get this. So how we can get it? Let's draw it quickly. We are having, let's say, 3 AND gate. So we are having one AND gate here like this. There's another AND gate I am having like this. We are also having another AND gate like this, right? So there are 3 AND gate like this. We are having X bar B in. So X bar we can get from here. This is X bar. Connected like this. And B in is here. So this is B in, right? Then Y B in. So Y is here. So this is Y. And here we can connect with B in. This is B in. And then we want X bar Y. So X bar is here. This is X bar. And Y is given here. Y is here. You can pass on Y like this, right? And now we are getting it. So you write it. This is X bar and this is B in. This is Y and this is B in. And this is X bar and this is Y. Now these things we can connect to OR gate. So let's say we are having one OR gate here like this, and here we are getting B out. Now these lines we can connect. like this. Okay, so this is like this. So with this, I'm going to end this lecture. Thank you.